Bismillahirrahmanirrahim. Today we are going to explain circle, equation, tangent and geometry links. Let's explore circle, one of the most elegant topic in the coordinate geometry. By the end of this video, you will understand how to find a circle equation, how to form an equation of tangents, and how circle geometry connects with algebra. Part 1. The basic equation of the circle. Then the general form or standard form of circle equation comes from, this is actually standard form, straight from its definition. What is the definition of the circle? A circle is the set of all points that are fixed distance from a fixed point. Now this is the set of points which are fixed at a fixed distance from a fixed point. This point is called HK, and the fixed point is center, and the fixed distance is the radius. Now this is your radius, fixed radius. That's our standard equation. If we have a center HK and the radius, that means that we are not at origin, and then every point of xy can anywhere in this circle boundary. So it must satisfy this equation: x minus h whole square plus y minus k whole square is equal to r square. This is our standard equation. For example, if we have center 3 minus 2, we can put h is equal to 3 and k is equal to minus 2. So x minus 3 whole square, y plus 2k whole square, and this radius is square, that is 5 square 25. Now let's explore more. Now the general equation of the circle. Now we know this is the equation HK. We have a radius x minus hl whole square plus y minus square. Now we are going to expand it. Now simplifying by the formula, perfect square formula, a square minus 2ab plus b square, x square minus 2hx plus h square plus y square minus 2y plus k square is equal to r square. Now we are going to arrange it: x square and then y square, then minus 2hx minus 2ky plus h square plus k square minus r square. Now these are terms we suppose for simplification, putting minus 2h as a 2g and minus 2k is equal to f. That seems to be good for plus. And now these terms, h square plus k square minus r square, we take it c. Now putting these values, we have x square plus y square plus 2gx plus 2f. This is the general form of equation of this circle. This is called general equation of this circle, and having center. Now the general form of the equation, we have x square plus y square plus 2j y plus c. Here g and f are constant because we have constant point. From this you can identify the center and radius. We know that center is minus g minus f because we have observed the minus, so our center will be minus g minus, and radius is g square plus f square minus c. For example, we have a circle with given center 2 minus 3. For example, we have given x square plus y square minus 4x plus 6y minus 3. This is your equation. Now you have to find out center and other things. Compare it with the standard form. We have comparing 2g means minus 4. So minus 2g is equal to minus 4. 2f means 6 because there is 6. Now it means g is with the x and y is with the 2f, and x square and y square is nothing. So 2g is minus 4. It means you will divide, you will get minus 2. 2f is equal to 6. It is, so f is equal to 3. That means center is minus g minus f. So we will change the sign. This minus 2 will become plus 2, and plus 3 will be equal to minus 3. So this is your center of this circle. Now radius of the circle, r is equal to under root g square plus f square minus q. We know that g is 4, that is g is minus 2. So minus 2 square plus 3 square minus c we will take from here. Remember that minus 3 multiplied by minus 3, and this root will continue, which simplifies 4 plus 9 plus 3 is equal to 4. So the radius is 4 unit. Now part 3, let's our equation of tangent to a circle. Now we are going to attach, this is tangent to a circle. A tangent is a straight line that just touches the circle at one point. This line is tangent line which is touching circle at point 3, 4. The key geometric fact there is that tangent is always perpendicular to the radius at that point of contact. So this point must be at 90 degree perpendicular or contact. So this is the key point you must remember. If you have a circle x minus h square plus y minus k square is equal to r square, then the equation of the tangent at point say x1 or y1, suppose on the circle is given by, we have x minus a1h, x minus h, and y minus k, y minus y1 minus k, and y minus k is equal to. Now we have what we have done, we have break this variable two brackets into x minus h1 and 1, which replace x1 by first and y1 plus. That is the easiest way to remember it, replaced by xy by x1 y1, or the general form. So this is called your equation of the tangent in the general form. If the circle x square plus y square plus 2gx plus y c is equal to, then the tangent at x1 is can be calculated like this: x multiplied by x1. X1 is the our given point, y plus y1 plus 2gx plus x1 plus 2fy plus 1 plus c is equal to 0. Let's do an example. For example, we have a x square plus y square. Now this is not matching with the general equation because here origin is 0. It means here g, f and f is 0, c may be minus 25. Now using the formula, this is your formula x1, xy1, here square on this. Now let's take it clearly. Now the given circle is x square plus y square 25. Compare, we have center at 0 and r is 5. Now step general form. Now we are going to solve it by general. So then the tangent x1 is, this is your equation of the tangent at x1. However, when the circle is centered at origin, it means g and f are 0. It means this f and g are 0 only, remaining c. Now however, so the formula is x1 x into x1 plus y1 1 r square, because g and f are 0, and c we can take minus r square. Step 2 standard, r square is 25, x1 is 3 4. Now we are going to put formula 3 and 4 and 25, because even in our r you can calculate r by g square and g square, only remaining minus c. So minus c is on 25. So simplify 3x plus 4y is equal to 25. Check the variable will satisfy the point. Now you can see that this point satisfies. We have checked. So our final answer is this: 3x plus 4y is 25. Now equation of the tangent we have discussed. Now part 4, length of the tangent. Now you can find out the length of the tangent. If you have draw a tangent from a point outside the circle, you can find its length by using formula. Now again the same formula you can remember, but it is in under root: x1 square y1 square plus 2gx1 plus 2fy1 plus c. Now for example, we have this equation and the external point is 6 8. Now we are going to put this point 6 square as a x1 and y 8 square plus 2 gx and g. What is our g? We have x 6 and g we can calculate from here. We have g minus 2 and f minus 3 we can calculate from here, plus 9 minus 3 plus 9, you will get the answer 37. So this is the way you can put the values and you will get the answer. Now this is, remember that this is your equation. We have to put here value also. Now you can put in this point in this. Now geometry connection. Circle connect beautifully with geometry. For example, if we draw two tangents from an external point on the circle, the tangents are always equal in length. These tangents are always OB and AB up to this point. They are equal. Also, when the center of the circle to the point of contact is perpendicular to me, these tangents are perpendicular. You take the radius. Problem: when a circle cuts at 2 points, the chord fold always satisfy the circle's equation. You can find where the line and circle intersect by solving their equations. X square plus y square y is equal to mx plus. Putting value you can calculate. This is the allow you to solve many find intersection points or shortest. Summary: the standard equation of this circle x minus h whole square plus y minus is equal to r. Expanding, we have this center is minus E and minus F G A squared, and the geometric circle helps us to explore tangents, chords, and intersecting circles. Look simple, but they connect algebra, geometry, and logic, making them one of the most beautiful chapters in the